constantly. It's weird. I watched part of the lecture yesterday and I was freaked out by it. Why? Because, okay, so, excuse me, kapow. Sympathetic division. Sympathetic, fight or flight. Fight or flight. Now, what do you need? What do you need for flight? You need energy, and lots of it. So it's no surprise that the sympathetic nervous system secretes epinephrine, because it stimulates your body. It gives you that energy you need to function. So as we start moving through this, we ended with this one, sympathetic nerves, sympathetic chain ganglia. So someone tell me where the chain ganglia is found. Where's the chain ganglia found? It's a simple answer, and I can even help you with that answer. Anyone? All right, watch this. There we go. See all those wonderful yellow things sticking out? Right next to the vertebral column, all the way down in the thoracolumbar region, right next to it, where all these guys stick out. Now this is an over-representation, okay? There are ganglia, a collection of cell bodies, right down the side, right next to the spinal cord, okay? And because they're right next to the spinal cord, literally come out of the spinal cord, into the chain ganglia, and then out to wherever we're going. Right down the side of it. So when it says sympathetic nerves, is that a lie? No, look at all these sympathetic nerves right here. Right up against the side of the spinal cord. So this is a great, what is that? Got my bell. Crazy, I don't know what that was. This is a great representation of how they pop out. So what's the hole called right here? The hole that they pop out of? It is a foramen. What is it called? What foramen? Intervertebral foramen. Oh my gosh, did we have to forget about 241? No. That's right. Start scratching on those neurons. Say, hello, wake up. We got to remember you. Intervertebral foramen. And if it's not a foramen, it is a notch. Fantastic. Good. Good. Okay, so the nerves, sympathetic nerves, where are they coming out? Thoracolumbar. Good. Let's move on. This is showing you exactly where they come out, but this is actually saying this is where the chain ganglia, okay, each sympathetic chain ganglia contains these. So we're coming out of the thoracolumbar region and we're dropping down to areas. Because isn't every single organ dually innervated but two? What are the two that are not dually innervated? Skin and adrenal medulla. Good. Good, you guys are on top of it. So preganglionic neurons limited to the spinal cord segment. Okay? Innervate neurons in cervical, inferior lumbar, sacral, sympathetic chain ganglia. So this is kind of giving you an idea of where they pop out, where they innervate. Provide postganglionic fibers through the gray rami. It's unmyelinated. Okay, to cervical, lumbar, and sacral spinal nerves. So we're saying we pop out and we either go up or down, and then we innervate. We go out to the appropriate organs. Only spinal nerves T1 through L2 have white rami. Every spinal nerve has gray rami. If it's gray, it's what? Non-myelinated. Fantastic. You guys are, this is good. This is good. Just needed a little wake up and we're solid. Postganglionic sympathetic fibers in the head, neck, lead, superior cervical sympathetic ganglia. And it's no surprise they're part of what? Cranial nerves. No surprise. Okay, no surprise that we're popping out cranial nerves. And what's 10 again? Vagus. Pretty much innervates all of our visceral organs. Why would we want the vagus to innervate the heart? What is sympathetic? What's the nickname? Fight or flight. If you're running what do you want your heart to do? Beat faster. It's actually kind of a no-brainer when you think about it that way. We're releasing epinephrine. We're running. What do our lungs and heart have to do? Go faster. So, cranial nerve number 10, vagus, goes out, innervates them and says, hey, we need to go faster. Beat faster. More force of contraction. And when we get to the cardiovascular system, when we start talking about the heart, guess what we're going to talk about? Cranial nerve. 10, the vagus nerve. It's going to be one of the nerves that we talk about all the time because it innervates the heart. We've got to speed the heart up. So this is showing you the cranial nerves and where they pop out. Notice the chain ganglia and the rami. Here's the chain ganglia right here. Cervical ganglia. Notice that we came out at T1 and then went up. So what did I say about the elevator and the staircase? We could come out, we could go up, or we could go down. Good. Wow, this is starting to look familiar. Where are your guys' handouts? Oh, in your folders? Pull them out. Pull them out. So, yeah, what we're talking about here is we're literally popping out T1, T2, T3, T4. We're popping out. Notice we have a plexus, okay? A plexus right here, which we actually can move around, go out to the heart and the lungs. Notice that this plexus is part of the cardiac and pulmonary. What did I just say had to be sped up if you're running? The heart and the lungs. They have to be sped up. They have to compensate for the amount of blood that's being pumped through your body. Now, as we go through this quarter, there are so many aha moments that you guys are going to be like, what? But there's also going to be a lot of times that I'm going to do this. It's false. It's fake. Whoever said it is wrong. So get rid of it. The media only tells you what they want you to hear. People who haven't actually gone through this only tell you what they heard from the media. So if I say that it's false, for instance, you only use 10% of your brain, that is clearly false. You may only use 10% of your cortical capacity, but you use 100% of your brain. Your neurons, all of them are firing. And we know that through functional MRI. So when people say, hey, you use 10% of your brain, whatever, just go back to where you went, and I'm going to keep going this way. The path of knowledge. Okay? So it does look familiar. What are we innervating? Now notice with the eyeball, it's duly innervated, so when you're kicking it on the couch, do you need to take in everything around you? No, just right here. But when you're running, and you're scared, it's this animal, huge, gigantic. You're running, you're scared. Okay? This should look familiar. Again, duly innervated on reproductive organs, but they're both excitatory, not inhibitory. Parasympathetic and sympathetic do two different jobs, but they're both being stimulated. The rest of the stuff, back and forth. If we're on the couch, we're going to stimulate sympathetic, digestive tract, so on and so on. If we're running a marathon, we're going to stimulate the heart and the lungs and lots of extra blood because we're running. Collateral ganglia, well, splanchnic nerves formed by preganglionic fibers that innervate collateral ganglia in the dorsal wall of the abdomen. So we have additional, collateral ganglia in the abdomen, originate as paired ganglia, usually fused together in adults. So obviously as children, we're growing into it, and as adults, they should be completely fused. Postganglionic fibers leave collateral ganglia, extend throughout the abdominal cavity, innervate variety of visceral tissues. Reduction of blood flow, energy by the organs, not vital to short-term survival. But what will we do? Release of stored energy. So we're going to go to the liver and say, hey, fight or flight, release a bunch of this energy. We're going to go to the stomach and the intestines and the colon, and we're going to say, you know what, just shut down. Now here's what's really crazy, and I'll elaborate on this a little bit later. When you're running, all your blood has to go to your legs and your arms and your lungs. That means all the blood that's in your stomach and your intestines gets moved out of that and into your legs, arms, and heart. When you're on the couch relaxing, all the blood that's supposed to be in your legs and your arms gets moved into your stomach. So let's take aha moment, okay? And I'll say this one more time when we get into the digestive system. Parents, all our lives, we were down at the river, floating the river. You eat your hot dog and all your goodies and everything, and your parents say, don't what? Go swimming. Don't go swimming. That's because all the blood from your hot dog and your sandwiches, all the blood from your body is in your stomach. So if you're a kid and you eat all this food, all the blood's right there, and then you dive in, do you have any blood in your legs or arms? No, and you cramp, and you sink to the bottom. There's an aha moment. You're probably told not to do it, but you're never told why not to do it. That's because all the blood's in your stomach, not in your legs and arms. Go figure. Okay? How many people have actually eaten something and their friend's like, oh, come on, let's go running. And you try to go running 30 minutes later and you're like, bull. Yeah, that's because your body's trying to make that transition. It can't handle it. It's saying, you know what, I can't do that. I can't make that transition from I'm taking care of your food to now I need blood for my legs. So you get sick, you vomit. Because what's your body's defense? Well, I need to run now. Let's get rid of anything I don't need to use. Blah. Okay, now I can run.
How long do you have to wait? Like 30 minutes?
An hour is probably better. When we get to the digestive system, I'll give you guys the time frame. It depends on what you eat. If you eat fatty food, 6 hours.
Yeah. Oh my.
It could take up to 6 hours to process the food. Okay, if you eat vegetables, carbs, 30 minutes. But yeah, big old fatty steak and a hot dog and mashed potatoes, even though it's a starch, yeah, it's time. And I don't know how true this is, but I heard this once, that John Wayne, does everybody know who John Wayne is? Okay? Man of man, man of man, the icon of being a man, nothing like a man and his horse. John Wayne. I guess from what I heard, again, I don't know the validity, I tried to look it up and it's sparse, that when he died, they found over 5 pounds of undigested red meat in his gut. But that's John Wayne, man. That's a proud thing to, that's my trophy. 5 pounds of red meat. Because no one's ever going to say, oh, you had 5 pounds of lettuce? Wow, you must drive a Prius. Yeah, no one's going to get excited about that, 5 pounds of lettuce. Okay, rabbit. So, what are we talking about? Well, reduced blood flow. We're going to take the blood away from the stomach. We're just going to say, you know what, you don't need it. We're going to take it away. Some of the other things, mesenteric ganglion, again, it's all about the stomach, the intestine, superior mesenteric ganglion. And when we look at the stomach, you're going to actually see this drape. And when I say drape, it literally is that, a big drape of fat when we get to the digestive tract, and I'll talk more about it. But this is an area where we're going to actually innervate the area, but we're going to say, you know what, we're going to shunt you down. We're going to shut you down because we need the blood, especially if we're in fight or flight. Celiac ganglion, a pair of interconnected masses of gray matter. Post-ganglionic fibers innervate stomach, liver, gallbladder, pancreas, and spleen. Okay, well, right off the bat, the liver is important because what are we doing? We're sequestering, we're actually picking up iron, we're picking up nutrients, we're picking up sugars. The other ones, we're just going to kind of shut them down. Okay, pancreas, that takes care of digestive tract, so we don't need that one. Gallbladder, again, that takes care of digestive tract. It secretes bile. Bile emulsifies fat. So it helps break down fat. So we're going to shut that one down. But liver has an actual huge store of sugar. And when we need it, we'll actually ask it to release it. And it'll release it right into the bloodstream, and guess what? You have energy. Now, it's a short-term energy, which means how many people in here had breakfast this morning? Like a good breakfast. That's what I thought. Coffee doesn't count. Okay, so if you're like, hey, coffee, no, that doesn't count. Okay, it's good, but it doesn't count. Which means now you're running off the reserves that are in your liver until you actually eat something. So it's a good way to think about it. That's why they say breakfast is good for you, even though I don't really eat breakfast. I've actually started eating something, like a little snack. Okay? So again, superior mesenteric ganglia, well, it's going to cover a huge portion, 2/3 of the large intestines. But because this is sympathetic, All we're going to do is shut it down. We're going to say, you know what, we don't need you. Okay, inferior mesenteric innervates portions of the large intestines, kidneys, urinary bladder, and sexual organs. Okay? Now, in fight or flight, do we need any of those things? No. No. Okay? We don't need the kidneys to do anything. We don't need the large intestine to do anything. Urinary bladder, we don't need to do anything. It will still function. I'm not saying it's like been gone. It's still going to do something for you, but it's not going to do it the way we would normally see it doing a rest and digest. This, on the other hand, extremely, extremely important. Adrenal medulla. Okay, preganglionic fibers enter the adrenal medulla, proceed to the center, the adrenal medulla, modified sympathetic ganglia. So what they're saying right there is that modified sympathetic ganglion, it's actually a cluster of what we would call, in the anatomy physiology world, a cluster of misplaced ganglia. So even though it's a glump of tissue, it's misplaced. It's actually considered a neuron. And that neuron will say, hey, you know what? You need this epinephrine. Let's dump it right into the bloodstream. Well, we need epinephrine for fight or flight, so there you go. Specialized neurons secrete hormones right into the bloodstream. That means it's going to be long-lived. It's going to be with you for a while. It does take some time to activate it. It's still fairly quick, but it's going to dump it all into the bloodstream and it's going to stay with you for a while. Neuroendocrine cells. Okay, so let's break this down. Well, we know what neuro means, right? Everybody understands what neuro means? Nervous system, neuron, so on and so on. How about endocrine? What does endo mean? Within. Within. And crin? Secrete. Nice. Good. Good. Refresher. It means secrete. So it's actually an endocrine gland and the neuron saying, hey, let's secrete this into the bloodstream. They're working together. To secrete what? Neurotransmitter epinephrine and norepinephrine. Okay, epinephrine, also called adrenaline. And we do have noradrenaline. So if you say norepinephrine, we do have noradrenaline. Okay, is 75 to 80% of the secretory output. Small amounts of norepinephrine get popped out of there. Remaining is norepinephrine or noradrenaline.
So that's the same thing.
They're pretty much the same thing. They do have some opposite functions, but they're mainly used for fight or flight. Okay, and if you go back to your neurotransmitters, and when we get to hormones, we'll actually get a little bit more information on what they do. Bloodstream carries the neurotransmitter throughout the body, causing a change in metabolic activities. Okay, it says different cells, including cells not innervated by sympathetic postganglionic fibers. Effects last longer because it's in the bloodstream. Now, when we say effects last longer, we have to say this. Let's close this. We have to say this. How much did your body secrete? That's number one. How much did you secrete? Here's another one. Okay? Let's run over here. I'm running. Notice this is my strut. Right over us. Come on. Right over here, right next to me. What's the difference? She's standing up straight. What's the difference? Yeah, size. Size. If she gets the same amount that I dump at the same time, who's going to be more amped up? She's going to be flying. Her head's probably going to pop off. Pow! It's too much. Yeah, so a certain amount for me may not do much. That same amount for me that didn't do much probably sent her through the roof. Okay? How many of those people have that friend that never drinks and every now and then they're like, oh, I'll have one beer, and the next thing you know they're like, what a glass of wine? It's the same thing. If I was to have a glass of wine, I'd be like, what, grape juice? Okay. But if I was to have 10 glasses of wine, there we go, it's a party. If she has one glass of wine, she's probably like, what, party? If she has 10, yeah, we're scooping her up with a shovel. Okay, time to go to bed. Okay, so does everybody get that idea? How much of that hormone got dumped into your body? Okay? If you just got a little bit, and you're a small person, probably the right amount. If you got a little bit and you're a big person like me, it's really not going to have much of an effect on you. Okay? So you got to weigh that out too. How much got shot in there? Experience, unbelievably, a lot of these slides won't ever say this, but experience has something to do with it. If you're a person that's prone to getting into vehicle accidents all the time, do you think when you get in a vehicle accident, you're going to be amped up? You're going to be like, really? Another one? No insurance company's going to love me, not even a lizard. Right? But if you're a person that never gets in an accident and you get in one, how much adrenaline do you think is going through your body? A lot. Yeah. So incidences can actually do that too. Why do you think they take police officers and they constantly keep training them? So they don't get amped up when they're out doing their job. They actually stay relatively calm. They get used to it. And we're going to talk about that because it's called upregulation and downregulation. We'll actually regulate the receptor sites per your body for how much is coming out. If you get it all the time, we're going to downregulate because we don't need it as much. We're used to it. Okay? And we'll talk about that. It's actually pretty nice to know that our body will actually make that change for us. Sympathetic activation, well, this is easy. Exercise. Get startled. Okay? Any of those things. Stress will activate it. Okay, releasing epinephrine at the peripheral synapse. Target specific effectors, smooth muscle fibers, blood vessels in the skin, activated in a reflex, do not involve other visceral effectors. So there you go. Okay, changes activities of the tissue and the organs. Okay, entire division responds, are controlled by sympathetic centers in the hypothalamus. Effects are not limited to peripheral tissue. So in other words, it'll go everywhere. Everywhere. Notice it says alter CNS activity. Really? Do you think that when you're really amped up, you have complete control of your mouth? No. When someone smashes into your car, I'm pretty sure the words that come out of your mouth are not the ones that you would take to church. I'm pretty sure of that. I'm pretty sure when you get in a car accident, you're saying some choice words. You probably even have like a list of them. You pull the list out and you're like, beep, 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 you, beep, beep, beep. Right? You have like one good word in the whole list. Okay, so yeah, it does alter the CNS. It says, you know what? Car accident, bad. Real bad. So changes caused by sympathetic activation. Increased alertness, feeling of energy and euphoria. Yeah, you could. Okay, did you guys hear about that guy that ran off the cliff? Seriously. You guys, everybody's sort of runner high, right? When you're running, they get kind of high at the fact that they're tired, but they're like, woohoo, I'm on top of the world. Well, I guess he had his headphones on, totally just didn't even see the sign. He's like, wah, and died. He actually ran off of a cliff. He was so high from running. He'd been running for like 10 miles. Kaput. Yeah. I'm pretty sure his CNS is altered now. Okay? But yeah. So feelings of euphoria, change in breathing, I would say so. Elevation in muscle tone. Now, I don't have to remind you all what muscle tone is. We all know what tone is. So the new people, did you get the tone thing?
I don't remember.
You don't remember if you got the tone thing? Not tone loc, but the tone thing. Okay, you don't even know who tone loc is. There's probably very few people that even know who tone loc is in here. That's scary. Susan's laughing because she does know who he is. She's like, I know. Okay, so tone is just keeping everything right in the middle. So if you have muscle tone, it's not completely flaccid, but it's not completely contracted. It's right in the middle. If you have vasotone, the blood vessels are right in the middle. They're not big, but they're not small. Okay, so it gives us a chance to actually, and I notice some of my students writing this down right now. You're like, God, thank you. That's good, that's fine. So yeah, tone, it's holding everything right in the middle. It's giving us a chance to actually go more or go less. And the perfect example I used last night, muscle tone, in the morning, when you're driving here, you're looking above the rear view mirror. At night, when you're driving home, you're looking below the rear view mirror. That's muscle tone. During the morning, it's actually stimulated. At night, you're kind of like, I want to go home. You're below the mirror. It's a perfect example of that. Okay? And if you're like me, I don't even change it. I just go up for a peek every now and then. Oh, they're tailgating me. I don't care. I feel like grandma looking through the steering wheel. I'm like, I got this. I'm going home. Okay, stimulation of sympathetic preganglionic neurons release acetylcholine at the synapse. Okay, excitatory effects on the ganglionic neurons. So, here's what I need you guys to do. Do you have that? This one right here. All right, kiddos. Boom. This is your friend. This is what this is talking about right now. This is why I said this is all in words and letters. This is much better. So pull this out, okay? Pull this little guy out. If you don't have it, just nuzzle up next to someone and peek off of theirs. Okay, so this is why it's so important. First off, let's start off with the top one. It says somatic nervous system. It's heavily myelinated. We know it's stimulatory. We know the chemicals ACH. Does everybody see that? ACH. Okay, and then we notice that it's going to skeletal muscle. So, perfect, we know that. Then we come down to sympathetic. Notice sympathetic, we have lightly myelinated preganglionic axons. We do release acetylcholine first. Okay, on the top one, it's non-myelinated and it's going to release norepinephrine. On the bottom one, it goes into the adrenal medulla and it releases epinephrine. Okay? Notice we drop down to parasympathetic, which is coming up next. Lightly myelinated, it releases ACH, but notice what the chemical, the final chemical that the parasympathetic releases. ACH again. Does everybody see that? Let me give this to you. Thank you. This is what this is talking about. Stimulation of sympathetic pre is going to release ACH. The post is going to release what? Either norepinephrine or epinephrine. So we could go with slides all day long. Hey, look, slides, ooh, yay. That image is 100% right there. So you need to color or highlight the fact that the first release is ACH, the second release is norepinephrine. We drop to the parasympathetic, first release ACH, second release ACH. And it's standard all the way across the board. Do you see any other neurotransmitters being released here? And on our first day, what did I say about this? The two neurotransmitters you needed to know the most about were what? Acetylcholine and epinephrine. Just like that. You need to go back. You need to see what they do. Go back to neurotransmitters. Look them up. What do they do? Now, obviously, every organ is going to be a little bit different, but if you're only dealing with two neurotransmitters, it's not a big deal. Go back, look them up, study what they do, make sure you understand what they do, because that's going to be the basis for the test on this chapter. We're talking about two systems, parasympathetic and sympathetic. How do they innervate, and what do they secrete? It's as simple as that. I wouldn't even have to study anymore or do any more slides. I could say, okay, we're done with this chapter. That's the basis for your studying for the test when we have this test. You have two divisions, sympathetic and parasympathetic. Do they have long pre's or short pre's? Do they have long posts or short posts? What do they secrete and how do they affect it? Okay, and that's why I had you guys go ahead and print these things up, because these are much better than any of the slides that we're going to get. I've used these in the past. They're fantastic. It's very simplistic. Tells you which ones are myelinated, which ones are not myelinated. Obviously, the heaviest myelinated are the somatic nervous system. Go ahead.
What is this in for? This happens.
Okay, so the next section right here that runs down is just giving you a generalization of what it does, what effector organs. So in somatic, it's always skeletal muscle. But in parasympathetic and sympathetic, it's all the visceral muscles, some skin, eyes, everything like that. So it's saying a collection of them. And over here, it can be either inhibitory or excitatory, but it's always excitatory in somatic. Always. ACH is always excitatory in skeletal muscle. What is ACH to the heart? Inhibitory. Okay, so you see how there's a difference? There you go. All right, so that's all this is saying. I could read off the slides for hours. That image does a better job. Way better than me lecturing for hours. Okay, so the same thing, it's telling you what it's doing. Now this right here is talking about ganglionic neurons, varicosities, okay? So this is part of the, it says various sympathetic neurotransmitters, varicosities. We're actually talking about wrapping around the smooth muscle. That's all that is. Varicosities is wrapping around smooth muscle. Okay, swollen segments packed with neurotransmitters pass along near the surface of the effector. Target organs, all of the intestines. So there's your varicosities. So notice the ganglionic neuron coming out, innervating the varicosities. But what's our secretion?
No.
Norepinephrine. So again, back to this sheet. Is it a true statement? Norepinephrine. Well, yes, it is. Okay? And it kind of gives you an idea of what norepinephrine would do to smooth muscle. Now, all terminals release norepinephrine at varicosities. Okay? Adrenergic neurons, they're called adrenergic neurons. Some ganglionic neurons release ACH instead, some do. Okay, we know that that's our pal parasympathetic. Are located in the body walls, skin, brain, and skeletal muscle, called cholinergic neurons. Okay, so some ganglionic neurons release ACH, and they're called cholinergic. The ones that release norepinephrine, adrenergic. Okay, so sympathetic stimulation, the release of epinephrine, norepinephrine, primarily from interactions of NE and E with two types of adrenergic membrane receptors, and you need to know these two types. The reason why you need to know the two types is because they're actually going to be the type per receptor on what they do. So you're going to have one type on an effector like skeletal muscle, and another type on smooth muscle or cardiac muscle, and it's going to have a different effect. So the types tell you what effect it's going to have. Okay, now it says activates enzyme inside of the cell membrane via G protein. So someone tell me what G protein is telling us it's doing right off the bat. How about this? For those people that weren't here, I apologize for the people that were here. Okay, I want you to pick this bottle up, but you can't pick it up until I do this. Tell her to pick it up. What just happened? Second messenger. Fantastic. Yeah, G protein's part of second messenger. I'm the first messenger. Louisa's the second messenger. This is a long process that occurs, cell membrane, to have you pick that up. Okay? What was direct messenger? Pick it up. There it is. As simple as that. So when we see G protein there, we have to think second messenger. Second messenger, a drawn out process. Is second messenger fast or slow? Yeah, it is. Good. Good, good, good. It's very slow. Okay? So, boom, alpha receptors, more common type of alpha receptor, release intracellular calcium ions from reserves. Okay, has an excitatory effect. Alpha has an excitatory effect. Alpha has an excitatory effect. How about that alpha that has a excitatory effect? Alpha 2 has an inhibitory effect. Okay, so back up, alpha 1 excitatory, alpha 2 inhibitory. Helps coordinate sympathetic and parasympathetic activations, which should be important because inhibitory. Do we want our stomach functioning in fight or flight? No. Beta receptors, well, affect membranes in many organs. Okay? Trigger metabolic changes. Stimulation increases intracellular cyclic AMP levels. So it enhances the second messenger. Let me say that one more time. The beta receptors enhance the second messenger. Now there are 3 types of beta receptors, 1, 2, and 3, just saying. Okay, 1 increases metabolic activity. 2 triggers relaxation of smooth muscle along the respiratory tract. So check this out. I ate some peanuts. My bronchioles did this. Am I exerting force right now? I'm squeezing down. Am I exerting force? Which one of those do we want to sprinkle on me to stop me from doing this? Beta 2. Because you secrete, and this is smooth muscle in my lungs, it does this. And I start breathing again. So what was the chemical that we gave to people that were in anaphylactic shock? Fantastic. 3, lipolysis. That's a fun word. Lipolysis. I'm pretty sure lots of us would like that to happen to us. The breakdown of fat, right? So the next time you're on your treadmill, you're doing this, someone looks at you, it's like, lipolysis. I got this. Yeah. It's the breakdown of triglycerides in adipocytes. And I'm sure, like you all know, we stand in front of the mirror and look at our adipocytes every morning and we think, oh, what exercise do I have to do? Okay, I was looking at the site for women to strengthen their side muscles right here, kind of lose this area right here, and I was like, I'm gonna try that. I'm gonna try that. And I did it, I was like, and at the end I couldn't even walk. I did like 20 of them. I'm like, I was hurting. I'm like, and they're asking you guys to do that? I think it's just a way to make you in pain. Like, let's torture women. Watch this. Yeah, and then the squeeze thing. Men aren't supposed to use those muscles. I got in that chair and I'm like, oh my. I felt a little exposed, by the way. And I'm in that chair and I'm like, oh, yeah. And at the end of the day, same thing. I'm like, really? I had to sit down to go potty. It was horrible. Man, the things they make us do, to lose weight. I just want to trigger beta 3. That's it. Let's just turn the beta 3 on. That'll be good by me. Aramis, have you ever done that exercise, the leg thing? Don't do it, buddy. Don't run. If someone says try this, be like, no, man, I got this. Whoo, man, craziness. Okay, so sympathetic stimulation and the release of ACH and NO. Whoa, what's NO? Come on, people, you know what it is. Nitric, not nitrous, this isn't Fast and the Furious, okay? Nitric oxide, and what does nitric oxide do? There's 1 million happy men in the world. Vasodilation, okay? It's naturally occurring in us, but in small amounts. It's not enough to cause the problems that we hear about, by people that are taking Viagra. Okay? But it's small amounts. And what does it do for us as human beings? Male and female, small amounts, vasodilation, the blood can now pass to that area easily. Okay? So NO, vasodilation. So it says innervates sweat glands of the skin, blood vessels of skeletal muscle. There's that dilation, blood vessels of skeletal muscle. We need more blood there. Okay, stimulates sweat secretion and dilation of blood vessels. Yeah, if you're running, what are the 2 things you want? To sweat, to cool you down, and vasodilation for more blood to get to that area. Ta-da! Okay, so nitric oxide, it's a vasodilator. That's all you need to know. It is a neurotransmitter. It is naturally occurring in us, but it's a vasodilator. Okay, autonomic nuclei, are contained in the mesencephalon, pons, and medulla, associated cranial nerves. But this is all about parasympathetic division now. Parasympathetic. Well, let's take everything that we just talked about. Let's see if we could do this. Let's see how easy this is. Let's take everything we talked about and reverse it. We just went through all of the sympathetic. All of the sympathetic. So take everything you know about sympathetic and say, I'm just going to reverse it. We just completed parasympathetic. What? Seriously. There are a couple anomalies here and there, but it's reversed. If we're not found in thoracolumbar, where are we found? Cranial sacral. Is it the opposite of what we were just talking about? Yes. If sympathetic is shutting down the stomach and kicking on the muscles, parasympathetic is going to shut down the muscles and turn on the stomach. If sympathetic dilates your pupils so that you can see everything around you, parasympathetic is going to constrict. If sympathetic uses norepinephrine and epinephrine, parasympathetic uses ACH. Everything is reversed. Everything. I could actually say we're done because everything is reversed. It's all you have to know. Okay? We were talking about adrenergic. Now we have to talk about cholinergic because of ACH. It is literally the opposite. Now we're going to go through just to see if there's major anomalies, but let me double check our time. There shouldn't be any major anomalies other than getting into the reproductive system. Where are we at with time?